introduction to quadratics. Quadratics are equations and are referred to as parabolas. This is what parabolas look like. Please, please, please be assured that these are not the quadratics that we want you to be focused on. They're not sideways parabolas. We're only focused on these ones that are concave down. They have a maximum. And we're only focused on the ones that are concave up. They have a minimum. Not sideways parabolas. Now, the domain of a quadratic function is always negative infinity to positive infinity. The vertex is an ordered pair. It is located at the minimum or the maximum of a parabola. The axes of symmetry is located at the x value. Is that correct? Yep. At the x value that exists at a parabola's minimum or maximum. The parent graph of a quadratic is y equals x squared. So below, I want you to go to y equals. You go to y equals. Put in the equation x squared. And then you're going to press second table. And you're going to start at the coordinate -3, x equals -3, and fill this out all the way down. Then you're going to go to the graph itself and graph the points. Then you get the domain, the range, the vertex, and the axes of symmetry. The vertex is a minimum or a maximum. I want you to write which one it is. It's one or the other. Go ahead, take about 2 minutes. I told you what to do. Go to y equals. Oh, I need to Yeah?
I never got my touchdown.
Oh. Oh no. Oh no. Hold on. Okay, guys. So, when you got the table of values, you should have gotten 9, -2, 4,
1, 0, 1, 1. I mean, I think
all right. So when I graph these points, I'm going to go left 3, up 9. So left 3, up 9. If you're still struggling with graphing, I'm showing you how to do it. Left 2, up 4. Left 2, up 4. Left 1, up 1. 0, 0. Right 1, up 1. Right 2, up 4. And right 3, up 9. Now, if you notice, this object is very symmetrical. Right down the middle, I want you to draw it. In the front, you have highlighters. Right down the middle, I want you to draw a dotted line. This is an imaginary line. It's the point where you can fold an object in half. Only certain objects have them. Parabolas have them. Absolute value functions have them. Maybe trig functions. but it's the line of symmetry. This line is an imaginary number. It's x equals 0 here, and I'll show you what I mean. You need to write it out. Axes of symmetry. It splits this parabola in half. X equals 0. That's my axes of symmetry. Now, if you want to be sure that this is an axis of symmetry, please hold your paper. But let's make the curve. Make the curve. So if you're drawing a V, I'm going to mark it wrong just because I can't. This is a U. This is more of a U than a V. Now, does this curve have a maximum or a minimum, Miss Smith? It's a minimum. It's right here. You draw a little arrow. Make sure you point that out. This is your vertex. This is the vertex. This vertex is a minimum. Now, the coordinates of this vertex are 0, 0. Your axis of symmetry is directly related to the x value in the vertex. It's directly related to the x value in the vertex. Now, ranges and domains. As I move towards the left, this domain is moving towards the left as well. So it's going towards negative infinity. If I go towards the right, the domain's getting bigger and bigger. It's going towards positive infinity. All quadratics have this domain. All quadratic functions have this domain. Now, for the range, my lowest y value is 0. Now, I can look at both sides. They're both going upwards. The y values increase on both sides, so I can conclude that this is going from 0 to positive infinity.
How do you know if it's Isn't it at the right?
Is it on the curve?
Yes.
Is there a hole there? Then it's a bracket. If it's on the curve, it's a bracket. 0 to positive infinity. Now, when you're filling out the information for the graphical characteristics of a parabola, the function family is the family of quadratics. The equation of the parent function is y equals x squared. The domain, it's not even a thing. It's negative infinity to positive infinity. I shouldn't even waste time on that. Automatic. Negative infinity to positive infinity. But your range, what's your lowest y value? Down here, -4, and it's a hard bracket. Up to where? Positive infinity. Now, does this have a local minimum or a local maximum? Minimum. And it's right here. This also happens to be my vertex. It's at positive 1, down 4, so 1, -4, 1, -4.
Are there not hard brackets on that?
No, this is just a point. If it's just a point, it's just parentheses, period. We're talking about intervals, more than one number, we're talking about brackets and things. Now, I know for a fact this is a U shape. It's not a V shape. And it's called a parabola. And my vertex is that minimum over here. 1, -4. What's your axis of symmetry? X equals 1. It's that x coordinate in your vertex. Draw a little arrow. You find the vertex, you find the axis of symmetry. You find the place where it flips over. Now, increasing and decreasing. This is where you guys mess up all the time. Your vertex is a critical point. Right here where the x value is 1, this vertex is a critical point. The axis of symmetry is a critical point. Now, coming from the left, we're decreasing. Y values are decreasing. But the domain, the interval for that domain, comes from negative infinity, and it goes over to 1. It's decreasing on this interval. You guys are looking at y values for whatever reason. We're not looking at y in that way to record this decreasing interval. Decreasing, we're coming from negative infinity to 1. Now, increasing, I start at 1, and this thing keeps increasing all the way over to forever towards the right, towards positive infinity. So from 1 to infinity, because 1's on the curve, it's a hard bracket. It's increasing. Now, is it constant ever? No. You can even write never. Just be firm about it. I might give you extra points for never ever. Anyways, erasing. X-intercepts. I had to count some x-intercepts wrong on a test. People thought they could go and say, right here where it says -1, they thought they could put x equals -1 and get away with it. So I marked it wrong. You need to write -1, 0. The other x-intercept is 3, 0. Now, what do we do with those x-intercepts? Those x values? We go to the part that says zeros and write x equals -1, 3. My y-intercept is 0, -3. Now, are there asymptotes? Are there these curves where it flattens off? No, none. In behavior, what are your y values doing on the left? This is the left. To positive infinity. On the right, what are they doing? If it's pointing up, you're going to positive infinity. Now, in general, quadratics come in the form, that form. I don't want to read it. We recognize the equation as f of x equals ax squared plus bx plus c. The quadratic has one x squared term as its highest term. So, for example, if I have x cubed plus x squared, this is not my highest term, my highest x term. This is. So this goes away. If I have 2x, this is not x squared. It's 2 times x. That's not a quadratic. Okay? If I have the absolute value of this, that's technically not a quadratic. That's an absolute value function. It has to be highest term x squared and none of that other stuff. And you cannot have 1 over x as a quadratic. So on the next page, you're going to be drawing a circle around all the equations or graphs that represent the quadratic function. And then you're going to label the other functions. So look at the first one. Is that a quadratic? No. Nope. Put an x and write, this is a rational function. This is a rational function. We have not encountered those yet, but we will. What about the next one? Is that a quadratic?
Yeah.
Is the x term, what's the highest x term? 2x, is that x squared?
No.
This is a linear function, actually. Because the highest x term is x to the 1 power. You be cautious. What about the next one?
Yes.
Yes. Why? Because the x is squared in the parentheses. So yes. Put a little circle around this. This is a quadratic. What about this one? Is the x term squared? It's going to be on your test.
No.
Just so you know. No. This is an exponential. When you have a number to the power of x, this is an exponential function. What about this one? Yes. We can see it. We can see it. What about the last one?
No.
Who said yes?
No.
Who said it? What kind of function is this? Absolute value. All right? Go ahead. Try to figure out what your transformations are. Please be mindful. Be mindful. Your parent function looks like this. Your vertex starts at 0, 0. So be mindful of the transformations that occurred. Did it slide? Did it dilate by shrinking or stretching? Or did it reflect? So go ahead, do the transformations, get the domain and range. Down below, graph this equation, answer the question, does this parabola open up or down? Get the vertex, get the axes of symmetry. Okay? Go ahead. Take about 3 minutes. Skip the whole bunch. I'm not redoing this video. Technically, one solution is the same number. Now, how many solutions here? 0. Or complex solutions. The solutions are complex. Bradley, you and your girl.
Kick y'all.
No, we're not doing.
I hate it. Yeah.
Make sure you have this 0 or a complex solution. Now, so right here, Miss Smith, how do I put equations into the calculator? It's right here. Put equations into the calculator. Miss Smith, how do I find solutions on the graphing calculator? How do I find the vertex, the minimum or the maximum? How do I find the y-intercept? It tells you. So go ahead, finish those last 2 problems here on this part. I'll use it for some kind of grade. You guys need some good grades. No, there's no extra credit.
In your class?
I don't want to.
It's the stuff.
I don't want to. It's going on YouTube.
It's